Welcome to Lecture 30. In this lecture, I am going to introduce you to the standard template library and specifically a container type known as vector. So the standard template library was proposed to become a part of the C++ standard back in 1993-94. It's some generic template programming that was done by some pretty smart people who were really good at C++. And so it's been included, and what that is good for is it helps those of us who are just your average Joe trying to program and solve problems. The program you see in front of you is taken from the book Beginning C++ Game Programming, copyright 2004. Michael Dawson's the author, and it's published by Thompson Course Technology. This is from a chapter, I think chapter 4. He, the author, is demonstrating vectors and using Hero's Inventory 2.0 to do it. First of all, I'm going to type the code in, and I'll only explain the stuff that's new. Okay, so if you want to use the vector container, and you'll come to know what that is, you need to include vector. And because all of the STL symbols are in the standard namespace, we'll go ahead for ease of specification. We'll say using namespace standard. Now, a vector is like an array, only it's dynamically expandable and shrinkable. It's an array under the covers, but a lot of the difficult parts of working with arrays have been wrapped in this vector capability. And so if I want to declare a vector, I say vector. And then what do I want to store in that vector? Let's say I want to store strings. So it's a funny syntax, but that is asking for a vector that's going to store strings. And then we'll call it inventory for this game that we're talking about. Then I will say inventory.pushback. This is a method, member method of vector, and it lets us create an object that stores a sword, and it pushes it onto the back of our vector or our dynamically growing array. And so we have one item on our inventory. Okay, I'll push another thing onto the back. Let's say that our hero also has armor. And we want to put maybe a shield. There we go. So this code declares inventory to be a vector of type string. And then inventory.pushback is the member method that we use to push things onto our dynamic array. Now, let's take a look at one of the other member methods. Called size. All right, and let's just stop there. Let's go out and let's compile this. Okay, it compiled. We run it, and it says we have 3 items. And you can see in the code here, we called inventory.size, and that's where the 3 came from. And you can see we have 3 here. If I add another item, let's say a mace. It's a weapon, old medieval weapon. Compile it, run it. Now I have 4 items. Okay, so let's move on. Some of these, are additions by me. So just to keep the... Okay. So now let's do Let's do a loop and say your items. That'll be our little header when we print it out to the display. And we'll do a basic for loop for int I equals 0, I less than inventory dot size. And then we'll just output. And now this is where you'll see that we can access a vector using a subscript or offset. Put a new line out. Okay, let's go compile this and see how this looks. And boom, sword, armor, shield, mace. It's getting much more Pythonic and easy to program as we continue down the C++ journey. Now here you see a simple replacement. We're going to overwrite sword with the battle axe just using array notation, but it works on the vector as well. And now, and then I'll copy lines 21 through 23, insert them here, compile, execute, and now you'll notice up here we had sword, armor, shield, mace. Now we have battle axe, armor, shield, mace. Okay, so now you see at lines 31, 32, we are counting the number of letters at subscript 0 of the inventory vector. It's got 10 letters. So if we count, B-A-T-T-L-E, that's 6. There's a space, that's 7. And 3 more for axe, that's 10. It looks good. All right, we'll continue on. Okay, and here we're going to delete, we're going to remove and shrink the vector by deleting the item at the back. The item at the back, if we go look up here, well, I'll have to, the item at the back should be the mace. Okay? And so after we do inventory pop back, I will take these 3 lines, copy them down here. Since I'm copying these lines, these would be a great great subject for creating a function to print these out, but that's okay. We won't worry about that now. So let's go ahead and let's compile this. And notice that your shield is destroyed in a fierce battle. And so after that shield is destroyed in a fierce battle, it says your items are battle axe, armor, and shield. So shield didn't actually get destroyed, mace did. And that's because I added mace. And so we'll just go down here and we'll update our code to say mace instead of the author's original intent, which was the shield. Okay, your mace is destroyed in a fierce battle, and so now the mace is gone from the list. Battle axe, armor, and shield, they're still there. All right, moving on. Inventory.clear. This is another member method, and this is how you would clear all of the items in your vector. And then we can do a conditional test and say if inventory.empty, another member method, which returns true or false. Then we're going to output cout I am taking some poetic license that the author did not include. Okay, and we didn't really need to return 0, but I put it in there anyway because that's what the author had. So here you can see in line 40, you were robbed of all your possessions, and then we call the clear method or send the clear message to the inventory object or vector. And then we test to say if it's empty, you have nothing. Otherwise, we're going to see the message, use what you have left for good. Okay, so let's compile that. Let's run it. Okay, you have nothing. So we can see from the message that was displayed that we took this branch here, that inventory.empty returned true after the clear message. Let's go here. And if I put in STL and say go, it actually takes me to containers. It says you were redirected to c++.com/STL, where it talks about a container is a holder object that stores a collection of other objects. They are implemented as class templates, which allows blah, blah, blah. And so you can read that, and you can see that there's other container class templates. And when it says template, that means it can work with other types. Rather than just string, it can also work with other types. We can create a vector of ints or doubles or floats or of structs that we create, and on and on and on. So we just looked at vector, and we didn't even look at all of vector. So if you click on vector, you can see it's in the standard namespace, as are all of the standard template library elements. And vectors are sequence containers representing arrays that can change in size. But you'll notice that there's a lot of, if we go to C++11, there's a lot of information here on constructors, destructors, overloaded operators. We haven't talked about iterators. I'll do that in my next video. Capacity. These are all member functions that you can call. And it tells you if they're public or not. So you can see our public interface to vector is quite large. And so might some of your type hierarchies when you're creating classes that will then be instantiated as objects. You can create quite a few public methods so that people using your class have a safe way to use your class without messing with the private internal parts of it. Okay, that's it for this video.